today we're going to talk about complex fractions. Okay, so complex fractions look a little crazy, but they're actually really fun. All right, so remember, when you guys write a fraction, that's basically the same thing as writing a division problem. Okay, so when we write 4 over 2 as a fraction, okay, that's basically the same as saying 4 divided by 2.
So likewise, like if you simplify a fraction like 4 halves to 2 over 1, is that you do the same thing with the problem?
Because 4 divided by 2 is 2, right?
But like when you write a problem on a thing where it says 2 halves.
You can, but normally we just don't write the 1 on the bottom. So a complex fraction is basically a fraction divided by a fraction. Now you're just writing things weird. Fraction divided by a fraction.
You can do that actually.
Yeah, you can. Isn't that crazy? So if you look at our first example, you see that guy? Fraction divided by a fraction, right? But whenever you see complex fractions like this, the first thing I want you to do is just draw your fraction line just a little bit longer. Then that way, it's just a little bit easier for you to differentiate between your numerator and your denominator. Right? Numerator and the denominator. Okay? So what I'm going to do is I'm going to rewrite this as a division problem, because that's what it is. 3 over 14 divided by 24 over 7. Right? That's what that is.
Definitely the same thing like when you flip it out.
Good. Yeah. Well, here's the thing. Do you see any like adding or subtracting fractions here? No. So good. Exactly what Tom said. You guys learned how to divide fractions. When you divide fractions, you're really doing same times flip. So, Timlin, first one stays the what?
The same.
Yeah, 3 over 14. After, what happens to the division sign? Oh no, division turns into, good, turns into a times. And then Ethan, what do I do with the second fraction? Somebody help him. Yes. You flip it. Same times flip. Flip the second one. 7 over 24. All right, so do you guys see any variables? Do I need a factor? No. So just multiply straight across. 3 times 7. 21 over, what is 14 times 24? 336. And then, it's just plain old numbers. Can we please simplify this? 21 over 336 and then turn it into a fraction.
1/16.
1/16. Good. No, not always. But you could, but it doesn't matter because you have your calculator, don't you? But you know what you can also do that I don't show you is cross simplify. Like 7 over 14 gives me 1 over 2, right? 3 over 24, that gives me 1 over 8. So then now you have smaller numbers and you can multiply. 1 over 16. Okay? So that's another way. All right, let's look at the second problem. All right, I'm going to draw my fraction bar just a little bit longer, then I know that that's my numerator and that's my denominator.
That confused me for a second.
I know, right?
Yeah.
That's what I'm saying. You got to draw that middle line, the fraction line, just a little bit longer. Did you find it though?
Yeah.
Okay. So now let's rewrite this the long way. horizontally. Okay, so I'm writing this out as a division problem, right? Do I need to factor anything, guys? No. So do I need to add and subtract any fractions? No. So good. Can I go straight into same times flip? Yeah, let's do it. Keep the first one the same. Change your division to a times. And this is the fun part. You flip the second one. And no, actually, I should say that this is the fun part. Because now what can I do?
Can you distribute?
No, don't you multiply it out. You have all these factors. They're all multiplying. If you have the same thing on the top and on the bottom, you can do what? Cross out. Right? This is the fun part. What can cross out?
X2.
Good. And then you see these regular numbers here? You can simplify those. What's 5 divided by 25? Huh? 5? No.
It's 1/5.
Good. 1/5. And what's left over?
X over X minus 1.
Good. On the top or on the bottom?
So top.
Good. Do I have to write that 1 in front? No, you don't have to. But is it wrong if you do? No. Right? There we go. Make it look a little bit prettier. There we go. Are we okay with that? Alright, good. So now, let's try this one. Okay, so the first thing we need to do is what?
Yeah.
Okay, but first, remember, we have to
Draw the line.
Yep, draw the line just a little bit longer. That's my numerator, that's my denominator. Okay? Make sure you're focused on this. Okay? Why do you have your headphone in? What are you listening to? Alright, make sure you're focused on this, okay? So we have the top, x squared minus 4 over x squared minus 2x plus 1.
So when you do the fraction bar like here,
Uh-huh.
does that mean that
That's where you're doing fraction divided by a fraction, right? It's just that there are so many lines there with all those fractions, you're just drawing it longer to show where it divides, okay? And really, you don't have to, but it's just good to, yeah. All right, so Timon said this one you've got an AM, but what about this one at the top?
That's those.
That one's dose, good. Guys, you have to factor, right? So up at the top, if you dose this guy,
It'd be X minus 2, X plus 2.
good for you guys. Yeah, you both had it. X minus 2, X plus 2. And then if we AM factor that one, let's see, two numbers that multiply to give me 1 and adds to give me negative 2.
Negative 1.
Negative 1 and
Negative 1.
good. Yeah. And that's just the plain old x squared, so I could say x minus 1 times x minus 1. And I'm going to rewrite this again, divided by x plus 2 over x minus 1. So it's still a divide situation, right? Can you factor any more?
No, but you can flip them.
Good. Now you should. Let's flip it. Let's do our same times flip. All right, what can you cross out?
X minus 1.
X minus 1 and
X plus 2.
x plus 2. You know, I know that there are two x minus 1s on the bottom, but remember what I told you, you can only cross out one for one, right?
Yeah.
All right, so what's left over?
X minus 2, X minus 1.
Good, x minus 2 over x minus 1. And you can put those in parentheses or not because they're the only factor left. That's it. How is this? Yeah, good. It's pretty fun, right? Okay. So since you guys are getting so good at this, we're going to add a little something to it, okay? So look at this one, all right? So same thing. I'm going to draw my line just a little bit longer. Now, my numerator and my denominator. Wait a minute. I have some fractions that are being added and subtracted, don't I? Right? So I have to do those first. You know what? I'm still going to write it out. No, I'm not doing division until I add and subtract these out first. Okay, so this is my numerator divided by 1 minus 1/8. Do you guys see that? Huh? Are we okay with this? It is everything on the top divided by everything on the bottom. So when you have fractions that are being subtracted or added in the numerator or in the denominator, you have to do those first and get one fraction before you can do the same time split. All right? So look at this first one. What is 1/4 plus 1/3?
Will you cross multiply?
No. Just put in your calculators. Remember, parentheses are on fractions. Everyone do this. Abner. Don't be lazy.
7/12.
Good. 7/12. All right, I got it down to one fraction, right? So then bring down your division sign. And then what's this guy? What's 1 minus 1/8?
7/8.
Good. I should said it at the same time. So now look, you have division divided by, oh my God, not division divided by, fraction divided by a fraction, right? Now what should I do? Yeah, same time split. Yeah. So if you ever have to add or subtract fractions, you got to do that first, and then you can do your same time split. Does that make sense? Okay, so let's do this. Same, keep the first one the same. Times, and what do you do with the second one? Flip it. So what do you get? 2/3? Anyone else? Is Tom right? Is it 2/3? That was really fast.
No, well, yeah, so I got the same thing.
You got the same thing?
Yeah.
Anyone else? Yeah? Good. You weren't wrong. That's right. You just said it so quickly. I just wanted to make sure everyone had a chance to try it too. Good. All right, so this one is 2/3. Isn't that pretty cool? This really complicated looking problem is just a little 2/3, right? Yeah. All right, so let's look at this one. Draw your fraction bar just a little bit longer. So I have my numerator and my denominator. Okay, so up top, I have 2 over x plus 2. Do I need to add a fraction, subtract a fraction, anything like that? Not on top, right? On top, I just have that one fraction. All right, so divided by, oh, what's happening on the denominator? Yeah, there's a fraction adding a fraction. So I'm going to put my little brackets here. Okay. 1 over x plus 2 plus 2 over x. All right, so I need to add this first before I can go into same time split. So let me see.
You can do x plus 2.
Well, you know what? Yeah, we need to find the LCD, right?
Yeah.
So fraction 1, we have x plus 2. What's in fraction 2?
X.
X. So what's my LCD?
X.
Good. X times x plus 2. That x is not the same as the x plus 2, right? Good. So that tells me that both of these denominators wants to look like that guy. Okay? So what do I need for the first one to look like the LCD? X. So I'm going to multiply by x on the bottom and on the top. Okay, but what does the other one need? X plus 2. Whenever you multiply on the bottom, you got to multiply on the top. All right, so then let's see. I'm going to write it as one fraction. I'm going to put x times x plus 2. And then I'm just going to write everything that's on top. So I have 1 times x. Can I just write x?
Yeah.
Plus 2 times x plus 2. Yes?
Yeah, you can distribute.
Yeah, and then distribute. Good. So this turns into x times x plus 2. Let's see, what's on top here? X plus 2x plus what?
Plus 4.
4. And then what?
Combine terms.
Good. Combine like terms. Great job, guys. 3x plus 4 over x times x plus 2. And now I can't combine anymore in like terms, right?
That's the answer.
No. Be careful. Now that we found that, bring all these guys down. Bring your division sign down. And then bring this fraction down. 2 over x plus 2.
You do the same as flip.
Yes. Good. And you know what? I'm actually going to draw an arrow up here. I'm going to rewrite it up here, okay? So I don't run out of room. So 2 over x plus 2. Since it's same times flip, I'm going to change that to times. And then what happens to the second one? Uh-huh. Good. Right? So now this is the fun part. What can you do?
Cross it out.
Yeah. You can cross out
X plus 2.
x plus 2. Then what's left over?
T over 2 over 3 x plus 4.
What else are you leaving out? You have the 2, this, and the x. 2x over 3x plus 4.
1.
let's try the next one. It's pretty fun, right? Oh, be careful with this one. Draw your fraction line. Then you have your numerator and your denominator, and let's rewrite this. You know, just an a squared up at the top, but you know, we like making these look like fractions, so how do I make it? Good. Super. Good. Yeah. So we need to find the LCD, right?
Yeah.
Because we have to subtract these fractions. So, okay, let's see.
Maybe 5 times 8.
Yeah. Your LCD is 5a. So fraction 1 needs a what to look like the LCD?
An
A.
And the other one needs 5.
And the other one needs a 5. Good.
So then that would be 4a minus 20 over 5.
All right, so I'm going to put 5a. Tom's got this. He said 4a minus, what's 4 times 5? 20.
Over 5a times 5a minus 5a.
No, just 5a, right? That's why you get them to have the same denominator. So you just write that one time.
Yeah.
You don't add them, multiply them?
No,
That's it.
because think about this.
Only thing you do
5/3 minus 1/3, right? Yeah, it's 4/3 because you don't subtract your denominators. Because then you'd end up with 0, and then that's not, right? So then that's the same thing here, okay?
That's it, right?
All right, but look, guys, 4a minus 20, can I factor?
Yeah, 2.
Yeah,
Or
even
4.
bigger,
4.
4. GCF factor that guy, and you get 4 times a minus 5 all over 5a, right? So I really like how this one looks because, I mean, we're almost done with this one. Bring down your divide. Bring down the a squared over 1. And then, what do I do now, guys?
The same as 4.
Good. Same times flip. Keep the first one the same. Change it to times. And you flip the second one. And you know, I really shouldn't take this so personally, but I feel a little bit offended when I do all this work and I can't even cross out anything.
Yeah.
Right? Because can we cross out anything? No. And that's okay, right? Just because you can't cross out anything doesn't mean that you did it wrong. All right? So, all right, well then we just have to multiply. So on the top, in the numerator, what do I have? You're not adding, you're multiplying. So you have the 5. And how many a's?
Maybe 8 and 3.
Good. And then all over 4 times a minus 5. Okay, so the next one, I need to draw my fraction bar just a little bit longer. Guys, this one's going to be double the fun because you have an x and a y. Let's rewrite this. In my numerator, I actually have a 1 over x plus 1 over y. Right? It's all in the top. I need to add those, guys. And then it's divided by x. And we said that's really x over 1, right? Now, guys, we can't do same times split yet. We got to add our first, we got to add our numerator, right? So, let's think about this. LCD, fraction 1, what do I have? X. Fraction 2, what do I have? So, what's my LCD? XY. They don't have anything in common. Everyone has to come down. So, what does that first fraction need to look like the LCD? What does this guy need? A y. Good. So let's multiply y. So what does the second one need to look like the LCD? An x. Right? Okay, so let's add them. Let's see. All over xy. What do I have? 1y plus 1x. Isn't that just y plus x? Yeah? Okay. Well, then bring down everybody else. Divided by x over 1. Yeah? Alright, so now I can do same times split. Keep the first one the same. And if you want to, you can rewrite that to x plus y if you like, alphabetizing it. But I don't think it really matters. Times. And you flip the second one, so 1 over x. Does anything cancel?
No.
No. Good.
Would it be GCF answer?
Huh?
Would it be an answer to GCF?
If you could GCF it, you would, but you can't here. Right? So there's nothing you can cancel because look, the x's, well, this y plus x, they're connected by a plus, right? Can't break them apart. So it's just y plus x over what? How many x's do you have on the bottom? So that's going to be x squared y. And that is your final answer for that one. Pretty good, right? Does this make sense? Like, does it feel a little bit natural? Do we have another example? All right, so the last one, right? Okay, so this one, we saved the craziest one for last, and this would be the hardest or the longest type of problem you would get with these complex, okay? So I'm going to draw my fraction line just a little bit longer, and that's my numerator, and that's my denominator, okay? So I'm going to rewrite this. It looks like I have to add stuff on the top, and I have to add stuff on the bottom, right? So let's put them in the brackets here. I'm going to turn that 1 into a 1 over 1, okay? Divided by 2 over 1 plus 3 over 2x. All right. So, guys, we have to find the LCD for the numerator, and we have to find the LCD for the denominator, and we got to add these fractions, don't we? Right? Okay, so let's take a few minutes and let's do that.
I have teacher discuss.
All right, so for my numerator over here, let's see, fraction 1, I have a 1, fraction 2, I have an x.
Maybe 1x.
Good. X or 1x, right? So then that tells me the first one needs an x, right? Does the second one need anything? No. So this becomes x plus 2 over x. Do you agree? Okay, good. All right, so let me look at the second bracket. So for my denominator, fraction 1, I have a 1.
2x.
Fraction 2, I have a 2x, so my LCD should be
2x.
good. Or 1 times 2x, which is just 2x. So that means that this first fraction needs a 2x. And the second one is good, right? So then this becomes, well, 2x on the bottom. 2x times 2 gives me what?
4x.
4x. 4x plus 3. Oh my goodness, how great is that, right? So now I have a fraction divided by a fraction. So now I can go into what?
Same as flip.
Good. Same times flip. Keep the first one the same. And I'm actually going to put parentheses around that x plus 2. Times. And then let's flip the second one. I'm going to put parentheses around this 4x plus 3. So now, guys, what do you see that's the same on the top and on the bottom? Thank you, Abner. This x and that x. Right?
Yeah.
Cross those out. Anything else that can be crossed out? No. So we have 2 times x plus 2 over 4x plus 3. And that's it. Good.